goes wide on the mountain tonight, not a footprint to be seen. A kingdom of isolation, and it looks like I'm the queen. The wind is howling like this swirling storm inside. Couldn't keep it, and heaven knows I've tried. Do 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 do. Tonight the snow is white in the mountains. There are no traces everywhere. A wealth of insulation, and it looks like I'm the queen. The wind is crying like this storm, I could not stop it. God knows I tried. So right now you're probably thinking two things. One, you're probably thinking that my singing voice is horrible. And it is. So that's correct. The other thing you're probably thinking is, why do those two renditions of Let It Go sound so different? Well, the first rendition is the original lyrics that were in the movie, and the second rendition is in English after I translated it from English to Spanish to Danish to Polish back to English. And you might not see it right now, but this is related to function composition. Let me show you why.
Alright, so today we're going to be learning about function composition. And before we go too in-depth into function composition, what we're going to be doing is first I just want to review function notation. So function notation, so like maybe if you had like f of x equals x squared plus 2, this would just be an example of an equation written in function notation. Now, in practice, it's absolutely identical to y equals x squared plus 2. And it is valid to say that f of x equals y. So why write it in f of x? Now, the thing is whenever you have a function, what you're doing is you're inputting x values here from a given domain, so of numbers. So like within the domain, you might have like 1, 2, 3, and then you're putting them into this equation to get values out. So you'll have x like 1, 2, 3, and then f of x, when you get the values out, or which is equal to y, you'll have 3, and then you'll have 6, and then 11, right? So f of x is just really the new values you get out, because you're translating all these values in this domain, x, by some value, by some function, f, to get new values. So that's really what f of x is signifying. So you've probably seen in mathematics stuff that looks like g of f of x, or h of g of f of x, or h of f of x, or, you know, all sorts of combobulations of this. And what this is really saying is you start with a domain x, and you change it to a new domain by a function f, and then you take that new domain created by this new function, and you change it into a new function by g to get g of f of x. Alright? So that's really what function composition is all about. Alright? So if I said, okay, f of x is equal to 2x, and g of x is equal to x squared plus 2, and then I asked you to write g of f of x, all you're doing is you're subbing in 2x in place of x, because g of x equals x squared plus 2, and so when you're subbing in f of x for x, what you're doing is you're just placing this 2 of x inside the x and x squared. So really what you're doing is just writing it like this. 2x squared plus 2, so g of f of x is equal to 4x squared plus 2. So now I'm just going to give a series of examples. So if I had f of x is equal to e of x, for example, and I had g of x equal to x cubed plus x squared plus x plus 1, g of f of x, would be equal to ex cubed plus ex squared plus ex plus 1. Now, if it was the other way around, f of g of x, it would be equivalent to e to the x cubed plus x squared plus x plus 1. So you can kind of see just how you're summing them in together. So now let's say we want to add functions together. They give you f of x equals 2x and g of x equals x squared plus 2x plus 3. And they want to know what is g of f of x plus f of g of x equal to. Well, you just simply take gx and sub f of x into it for g of f of x, so that would be 2x squared plus 2x plus 3. And then f of g of x is just kind of take the opposite. So 2 times 2x squared plus 2x plus 3. And so when you add these together, you get 4x squared plus 4x plus 3 plus 2x squared plus 4x plus 6. And then when you add them together, you get 6x squared plus 8x plus 9. And that's what it's equal to. Or what if I said f of x minus g of x. I'm just going to put this right over, just remind you what these two functions are. So fx equals 2x, gx equals x squared plus 2x plus 3. I just don't want to make sure you guys don't forget that. So f of x is 2 of x. You just sub that in there. So you have 2 of x minus x squared plus 2x plus 3. And when you, so then you get this. So fx minus gx equals x squared minus 3. And so pretty much that's really what the basics of function composition. It really doesn't get much more complicated than that. So now you're probably wondering, what was the whole deal with frozen at the beginning of the video? How does this relate to function composition? Well, I'm going to show you real quick. So here are the words of the original song, Let It Go, in English. I translated it into Spanish. I translated that into Danish. And then I translated that into Polish. And then I translated the Polish stuff back into English. And let's let these translations be modeled by functions f, g, h, and j. So now if I let x be the original words of Let It Go, now, basically you can model it using function composition. So here's x, and to represent the function that translates the English words into Spanish, I just write f of x. To represent how these translated words into Spanish are translated then into Danish, it's g of f of x. To show, then to translate all of this into Polish, it's h of g of f of x. And then to translate it all the way back into English, it's just j of h of g of f of x. And so this really, even though it doesn't use numbers, this really is a practical application of function composition. This is showing the final translation after going from English to Spanish to Danish to Polish all the way back to English. And this is a form of function composition. So I hope this really helps you understand function composition. And if you have any questions, feel free to leave questions in the comments below and I'll try to answer them.